In this lecture, we are going to look at how to simulate stock prices in code. As usual, you can look at the title of the notebook to determine what notebook we are currently looking at. Alright, so the first algorithm we're going to look at is the one where we sample from the existing returns. First, we set the initial price P0 to be the final close price of our dataset. Next, we create a list of prices. Currently, this contains only P0. Next, we create a list of returns by taking the Starbucks returns column and dropping the missing values. Next, we enter a loop. I've assumed that we want to simulate over 100 days, but obviously this choice is arbitrary. Next, we use the np.random.choice function to randomly select a return from our set of returns. We'll call this R. Next, we find the next price by taking the last price in our prices list and multiplying that by 1 plus R. We'll call this P. Finally, we append P to our list of prices. When we're outside the loop, we plot the prices as a time series. So you can look at this and decide whether or not this seems like a reasonable and realistic evolution of the stock price. Next, we do a simulation using a fitted t-distribution. Since you already know how to fit a t-distribution, I'm sure this is not too surprising. We call t.fit, and this returns df, location, and scale. Next, we grab P0 and instantiate our prices list as we did previously. Next, we enter a loop that goes for 100 steps. Inside the loop, we sample from our t-distribution. This is accomplished by calling the rvs function. The return value is a sample from the distribution, which is a simulated stock return. Next, we calculate the next price by taking the last price and multiplying by 1 plus R. As before, we save this to our prices list, and then we plot the final prices. Alright, so I think this looks reasonable. I think if I were to show you the two plots side by side, you wouldn't be able to tell which one came from which algorithm.